Latest research reveals our universe could be nestled inside a black hole. Among this black hole might itself lie within another universe, and black holes in our own cosmos may cradle entire other universes. It's like a cosmic Russian doll. Layers within layers, just like Matryoshka dolls creating an endless cosmic loop. Today, we'll explore what's going on here. Recently, Webb Space Telescope captured distant galaxies never seen before and uncovered puzzling cosmic mysteries, and this is at Kansas State University. A leading study, the research team analyzed 263 samples formed after the Big Bang. 300-million-year-old galaxy was analyzed. This data comes from the deep space of the SCARF telescope extracellular cyclotron. They discovered that in these galaxies, about 2/3 of them rotate clockwise, and only 1/3 is rotated counterclockwise. This conclusion has puzzled scientists. According to cosmological principles, that the universe is uniform on large scales and of the same sex, so the rotation directions of the galaxies should be randomly distributed. The probability of clockwise and counterclockwise is 50%. It's like flipping a coin 100 times. The ratio of front and back should be close to 1-to-1. But it turns out there are twice as many heads as tails. 1 wonders. The coin may be frozen similarly. The skewness of the rotation of galaxies, suggesting some deep mechanism affecting the universe. This discovery broke in cosmology basic assumptions about uniformity. It challenges existing theoretical models. According to the standard cosmological model, about 80 billion years ago, universe, all matter and energy are compressed in extreme heat in a dense state. Then in an instant start going in all directions. Rapid expansion as the universe expands and cools. Matter under attractive force. First, hydrogen and damage were formed, then form stars and galaxies. This process should be inherently completely random. The direction of rotation of the galaxy should be determined by the local conditions at the time of formation. Previous research has indeed supported this view. So why? The proportion of galaxies rotating clockwise is obviously too high. Some physicists have proposed that cosmology, one of the most radical theories, our entire universe, it may exist inside a black hole. Now, this didn't come out of nowhere. It's a hypothesis backed by sound science. The theory was originally developed by theoretical physicist Rajpathri Arun, proposed in the early 1970s. In the standard model, the universe was born from a beginning, and the simple answer is this: it refers to the infinity of the space-time rate. The density of matter is infinitesimal point. Existing laws of physics fails under these extreme conditions, and in black hole cosmology, we believe that our universe originated from black holes in the parent universe. Collapsing matter is not destroyed at the beginning. It rebounded and started to expand. In the world of black hole events created our universe. But how do black holes hold the entire universe? What does this have to do with spinning galaxies? In traditional physics, when matter falls into a black hole, it is squeezed to the starting point. The similarity between this point and the beginning of the universe is have infinite density and infinitely small in size. When the concept of infinity is introduced in physics, it often means that traditional theories, its nature cannot be described. So when matter is compressed to its limit, it doesn't have to be the starting point. According to quantum mechanics, when matter is compressed to the extreme, there may be some peculiar effects. This quantum effect may stop black holes' formation of starting point. Not only is the material not squeezed to the starting point, in the contrary, after reaching the maximum density limit, just bounce back and starts to expand outward, and this process can only be observed from inside a black hole from the perspective of the outer parent universe. And this black hole is just an ordinary black hole. Its size is determined by the quality, but inside an independent time and space, the expanding universe is unfolding. It's like the inside of a balloon. Put on another balloon in the mathematical model of general relativity is fully open to this possibility. Black holes with agitation can generate independent spatiotemporal regions inside a black hole. It is possible to form new subuniverses, and it has its own physical laws and dimensional structure. If this hypothesis holds true, then there is a shocking possibility. Our universe, it may exist in a black hole. This black hole might itself lie within another universe. The black holes in our universe may also contain other universes. It's like a cosmic Russian doll. Layers within layers. Just like Matryoshka dolls, then this and surrounding galactic rotation discovered by the NEC telescope. What's the connection? What matters is the type of black hole. In our universe, most black holes in nature are not static. They all keep spinning. The rotating black hole will destroy it. Part of the momentum is transferred to the universe formed inside. In physics, a spinning black hole is often referred to as a Kerr black hole. It's named after a mathematician named Roy Kerr, because he was born in 1963 solving the Einstein equation for a rotating black hole. These kinds of black holes not only devour matter, it also rotates it like a cosmic vortex. A rotating black hole generates a phenomenon called a frame, the effect of dragging, because as the black hole rotates, drags the surrounding space-time structure. What if our universe was born out of a spin inside a black hole? Then the rotation properties of the parent black hole may endow the entire universe with subtlety and basic directionality. This intrinsic propensity to spin may affect the aggregation of substances, collection patterns, and galaxy formation processes. Physicist Nick Demosicki Einstein-Gedang theory developed this idea. The theory extended Einstein's general theory of relativity, added the properties of spatiotemporal brane fields. In this model, brane fields generate repulsive forces so that the substance doesn't collapse to its starting point, it rebounded. This would explain why Webb telescope observed anomalies in the rotation of galaxies. Suppose that from our perspective the parent black hole rotates clockwise, then the galaxies in our universe also more likely to rotate clockwise. Of course, that doesn't mean counterclockwise. Galaxies cannot form after all. We have already observed, but the fundamental rotation of the parent black hole may be clockwise. Higher probability of direction resulting in the scarf. The telescope observed a situation of about 2:1, and here's what's even more remarkable. This is more evident in galaxies formed in the early universe, because then the effect of the rotation of the parent black hole is the most intense, and as the universe evolves and becomes more complex, increased interaction, this effect may be gradually diluted. Of course, according to the core concept of scientific principles, extraordinary evidence is required if we don't resort to the cosmic nesting doll hypothesis. Is there any other way to explain the circumference? What about the discovery of the Neck telescope? But scientific rigor demands that we, before reaching a revolutionary conclusion, all possibilities need to be fully considered, especially those with more traditional theories. Therefore, the current maximum guarantee. One explanation is observational bias. Asterisks determine the direction of rotation of the galaxy. It involves very sophisticated image analysis. During data collection or processing, if there is some systematic bias, may cause a certain direction of rotation to be optimized. First, identify. For example, the viewing angle of the galaxy may affect judging the direction of rotation, or there is a bias in the sample selected for analysis will also affect the results of observations, and in previous studies never before have such glaring biases been found. Different research teams using different telescopes and methods, the resulting distribution of galaxy rotation, most of them are more balanced. There's another explanation. It involves major issues that we do not fully understand. Scale, cosmic structure. There are a lot of galaxies in the universe, a cosmic web of filaments and voids. If our region of the universe, the existence of some large-scale motion or structure may affect the formation of galaxies and the way they spin. Other physicists have proposed the universe itself may be at a fundamental level. It's inherently defensive. But it's not because we're inside a black hole, but from other we don't yet understand the physical mechanism. It is also worth mentioning that although the sample of the SCARF telescope is groundbreaking, but it's fairly limited in scope. The results of the study erebused on 263 recognizable rotating galaxies. This sample size relative to the billions of galaxies in the observable universe, it's just a tiny part. If the universe is really inside a black hole, that would fundamentally change our understanding of the universe. Awareness of origin and structure. The universe no longer began with a mysterious beginning. It's part of a much longer cosmic cycle. Every generation of the universe may have slightly different physical properties. Some universes may be better than others, more suitable for forming complex structure and life. It should be emphasized that black hole cosmology is still a speculative theory. It's a hypothesis at the cutting edge of science. Requires rigorous inspection and verification, but that's the way science works. Anomalies observed by accident and make bold assumptions, after rigorous verification, ultimately lead to a revolutionary breakthrough, from Copernicus reaching to Einstein's Discovery of attractive forces bending space-time have gone through this process. He reminds us scientific progress never a walk down a given track, but in the fog of trial and error the crusade closer to the truth.